Today we're working in section 9.2. This is problem number 40. Before we get to that, we're going to go over a couple of things I want to make sure I have in your guys' ear before you start. The rubrics for the AP exam typically require a test statistic in addition to the p-value. That means although I'm going to show you how to use the calculator on how to get your p-value and how to do your test of significance in the calculator, you're also going to need to, or you would be safe to, find the test statistic as well. So let's find the z-score. And then all calculations are done assuming that the null is true. That means every time you're working through your hypothesis, again, going back to the court case, we're assuming that you are innocent until proven guilty. So we're assuming that the null hypothesis is true. So all the numbers that we're going to run off of are according to the null hypothesis. All right, so the problem that we're going to be working on today is a drug manufacturer claims that less than 10% of patients who take the new drug for treating Alzheimer's disease will experience nausea. To test this claim, the researchers conduct an experiment. They give the new drug to a random sample of 300 out of 5,000 Alzheimer's patients whose families have given informed consent for the patients to participate in the study. In all, 25 of the subjects experienced nausea. Use these data to perform a test of the drug manufacturer's claim at the alpha equal 0.05 significance level. Now going back through the problem, looking at the key features that are really going to matter to us, notice that they claim that less than 10%. That's going to give us a direction for our hypotheses. We are told that there's a random sample. That goes back to our conditions of random sample necessary in order for it to be an unbiased estimator and in order for us to be able to infer upon the larger population. Then we have an n equal to 300 because that's what we actually sampled out of all the Alzheimer's patients that they had. Then we have an x equal to 25 because those are the ones that experience the nausea. And then finally we know that our alpha level is 0.05. Now we're going to take this to begin by writing our hypotheses. So to begin with, we're going to write our hypotheses just as I stated earlier. We have our parameter of interest is a true proportion of patients who would experience nausea on this day, or on this drug, sorry. Then our proportion is the 0.10, that goes back to our claim, and against the alternative of it being less than 0.10. So we're checking their claim to see if it's true, if there really is less than 10% of patients who get it. So the only thing we can test that against is just the 0.10. We have the alpha level that was already set at 0.05. And we know that our sample proportion is a 25 out of 300. So the p-hat we're going to be testing this against will be 0.083. Next thing we want to do is check our conditions. They're the same conditions as you had in the last chapter, the same conditions you've been seeing over and over again. We have our SRS, our independence, and our large counts. So we know that an SRS of 300 patients was taken. We know 300 is less than 10% of the 5,000. We also know that the n times p's are all greater than or equal to 10. So we're going to use a 1 proportion z-test. Now to do your 1 proportion z-test, we can do that in the calculator. So I'm going to go to my calculator. I'm going to zoom out here so you can see a little bit more of the calculator. Okay, so to get to where I just was, to get to the 1 proportion z-test, you're going to press stat, move over to tests. Then I'm going to go to the 1 proportion z-test, hit enter. It asks for our p-naught, that's the proportion in the null hypothesis. So that's going to be 0.10. Then it asks for our x, remember that was 25. It asks for the n, that was 300. Then down here, this is asking you for what your alternative hypothesis is. So we had a less than for alternative, so we're going to go right here to the less than, and then we're going to hit calculate. And that gives us everything that we need to know. Now we know that the z-score is supposed to be negative 0.962. Again, I'm going to show that work being done in my problem. Then I have my p-hat, and my n. That p given is your p-value. That's the probability of this occurring by chance alone. So to write that up, I'm going to say, I'm going to show my work for my z-score, getting out exactly like the calculator did. Run through this in the calculator, make sure it works out correctly. Then my p-value came straight from that, or if you like to, that's the same thing as going in table A and getting the probability from there. Then to judge that, I'm judging it against the alpha level of 0.05. Because 0.1685 is greater than 0.05, I need to fail to reject, and I'm writing my conclusion in context. We do not have statistically significant evidence that the true proportion of patients who would experience nausea on this drug is less than 10%. So that is all the work you would want to show to get full credit for this test as significant.